Hi, good afternoon. Thanks for coming. Thanks for making it to the afternoon of the fourth day. My name's David Ingham. I'm a program manager on the Service Bus team, and I'm going to talk to you today about building hybrid applications using the Azure Service Bus. So we've got a lot of new stuff to talk about today, but I'm going to start off with an overview, tell you about the Service Bus capabilities. So just from a show of hands, how many folks in the room have used Service Bus? Okay, good. So I think there's something here for everyone. There's some introductory material, and then there's some more advanced material and announcements of new things that we've been doing. Okay, so let's begin. So Service Bus provides a unified set of messaging capabilities. It provides direct messaging, connected direct messaging, and it provides asynchronous buffered brokered messaging. And it provides all of those capabilities with a unified management and observation experience. So you can go to the Windows Azure portal, you can use tooling for Visual Studio and other tools, and you can manage and monitor your entities using those tools. So the two halves of Service Bus. First of all, the relay. The relay is the Service Bus entity that provides the direct messaging capability, and it's really useful for interconnecting applications across network boundaries. And then the brokered messaging capabilities, they provide message queuing and publish and subscribe messaging. So that's more like traditional message-oriented middleware. And collectively, these set of capabilities make it easy for you to build hybrid applications. And we use the term hybrid applications to mean those that incorporate components that are running on-premise and components that are running up in the cloud. And Service Bus is a great way to interconnect those components together to create your application. Okay, so let's first talk about the relay. So with the relay, you can take a standard WCF service and you can configure that service to use the relay binding. And when you start up that service, instead of that service opening a local port, opening a TCP or an HTTP port locally, it makes an outbound call up into the relay and registers an endpoint up in the relay service. You can then take that name and you can give that name to your business partner who's running behind another firewall in their organization. And when they start their client for that service, instead of talking to the service directly, it makes an outbound call up to the relay, and the relay joins those two connections together and flows the requests and responses from the client within one organization to the service within another organization. So it means that you're able to take a service and project it for use for your business partners without anyone having to open any ports on their firewall. And it does this in a smart way. It will attempt to establish connectivity to the relay using TCP. If TCP is unavailable due to firewall restrictions, then it will negotiate down to HTTP or HTTPS. So let's see what that looks like. I've got a little demo here. So flipping over to Visual Studio, this is a simple little WCF contract. So a single interface that has a single operation get image. It's using the WCF HTTP programming model here. You can see we've decorated this with WebGet. And the implementation of this service is simply loading a file from the file system and making that available as a message when the service gets called. So let me start that up. So the interesting bit about this service is in the configuration. So if we look here, we can see that the service is defined with an endpoint, we call it the relay endpoint. There's the contract that we just looked at. And we can see it's configured to use the web HTTP relay binding. The only other bit of configuration information we've got here is this behavior called the shared secret client credentials. So if we look further down in our configuration file, we'll find that here. And what this is doing is this is providing the credentials to allow your service to project that endpoint in the relay. Okay, so when we run that, this thing starts up and starts listening to a particular address. Now I've put the address there if any of you guys want to get your computers or your phones out and hit up that address. When you do that, your request will go up to the relay and then down to that service that's running on my machine, and my machine will serve that image from the file system. So if I open up a web browser, I can see this image that is returned from, so that's coming from my machine, and if any of you guys hit that same URL, you'll get the same image through your browsers. So that's showing how I can take a WCF service running locally, project it to the cloud, and allow anyone to access that service. I can obviously restrict who accesses that service as well, should I so desire. Okay, so that's the relay. I'm going to shut that down now, so you've missed your chance. Okay, back to the slides. Okay, so next up I'm going to talk about brokered messaging. Now, as I mentioned, brokered messaging, we have the notion of message queues and publish and subscribe messaging. And what brokered messaging brings to your application is this notion of loose coupling. So let me just illustrate what I mean by loose coupling before I talk about the details of these queues and topics. So imagine this situation where we have a tightly coupled world. We've got a web front end that's acting as a store, and that web front end is connected to some back-end service, illustrated here as a shipping service. And we've got a direct connectivity between all of these components. So the web front end is making synchronous RPC style requests on the back-end service. Now imagine what happens when we have a problem. Something goes wrong in the back end. And now, because this is a synchronous, directly connected wire up here between the front end and the back end, that has a direct impact on the front end. So it now means that the front end is unable to submit orders into the system. So the alternative, the loosely coupled world, here I'm going to introduce a queue between these components. So now what's going to happen is when the front end submits an order, it sends a message into the order queue, and then the back-end service goes to that queue and and consumes the orders from it. So now let's illustrate what happens when we have the problem with the back end. Here, the front end is still able to submit orders. So those orders go into the queue in the form of messages, and they just sit there until the back-end service comes back online to consume them. So when it does, the messages will flow from the queue into the shipping service. So this is something we call temporal decoupling. It means that your components in your system now no longer all have to be online at the same time. You can take a component down for maintenance, or in the situation where a component fails, the whole of your system isn't impacted by that. So that's temporal decoupling. It also gives you this notion of load leveling, in that the front end can be submitting orders that the load can vary dramatically during the course of a business day, say. So at times of peak load, what will happen is those messages will just back up in the order queue, and the back-end service will just process those messages at a steady pace until it's eaten up the backlog of orders in the queue. So it gives you that load leveling capability. That means you only have to provision your service for average load rather than for peak load. The other thing you get with a queue is load balancing. If the load increases to the point where one back-end service can't handle all of the load, you can create multiple instances of your back-end service, and you can have those guys listen to the order queue, and the work in the order queue is then distributed among those instances of the back-end service. Okay, so that's loose coupling. So that's the key capabilities that our brokered messaging capabilities provide you. So going back to the service bus brokered messaging entities, we have, there's the service bus queue. So the service bus queue, we send messages in. So I have a sender here that sends messages into the queue. And I have a receiver that consumes messages from the queue, just like you saw in the previous example. I can have multiple senders sending messages in, and I can have multiple receivers consuming messages from the queue. But the salient point here is that each message that gets sent by any one of those senders is only consumed by one of those receivers. Okay, so each message is consumed just once. So moving on to the topic, the send side of the topic is exactly the same. So I have a sender, I send messages to a topic, the code looks the same as if I'm using a queue. The receive side is slightly different. So instead of receiving from the queue itself, I receive from a subscription. So a topic has a number of subscriptions that I can create. If I have multiple receivers, I can have multiple subscriptions for each of those receivers. And what that means is that every message that gets sent to the topic, a copy of that message is made available to each of those receivers. So it's a one-to-many pattern. One message comes in, potentially many messages are going out, depending upon the number of subscriptions. I can also have multiple senders sending in, just like before. And I can still do competing consumer. So on a single subscription, I can scale out my back-end processing on that single subscription. So here, in this scenario, each message that comes in will go to the top receiver, the bottom receiver, and one of the three receivers connected to the middle subscription. I can also do filtering with subscriptions. So I can specify rules on each of those subscriptions that say which of the messages I'm interested in. So by default, all the messages that are published go through to the receiver. I can specify a filter based upon the contents of the message that restricts the set of messages that flow through. And so if we look at what the messages themselves look like, you can see that there's a property bag consisting of key value pairs. So you can put arbitrary business data in that property bag. You might put store ID equals 1234 as a property of your message. The body of the message is opaque. The broker doesn't look at the body of the message, but it uses the properties to be able to execute those filters that I mentioned. So if I say that my message has store ID equals 1234, and one of my subscription rules says only messages with subscription ID 1234, with store ID 1234, only that receiver is going to get that message. That receiver is going to get that message, along with other receivers that have matching filters that match those message properties. Okay, so that's the basics. Let's see this in action. So I've got a demo scenario here, something we call MarkView. It's a retail management system. And the notion is that we've got retail points of sale, and we've got a back-end inventory and fulfillment center. And so the sales traffic from the front end goes through this IT system in the middle and ends up at the inventory at the back end. But we also want to take this stream of data and do other interesting things with it. We want maybe to take an audit tap of that data flow. We might want to pull it into a real-time analysis tool so that management can look in real time at what's happening to a single point of sale, to a store, or to many stores. And we also want to be able to just give that real-time insight as to what's happening in the system. So let's build up an architecture to solve this problem. So starting out, we could put a queue between our front-end points of sale and our inventory system, and we get the advantages of temporal decoupling that I mentioned before. We also get load leveling. When we scale up the number of front-end stores, then we can scale out the back ends accordingly, and we get load balancing. But I said that we wanted to use this stream of data and do other interesting things with it. So if I change that from being a queue to being a topic, and I create a couple of subscriptions on that topic. So the bottom subscription there is connected to the inventory back end. So that data path is unchanged. Messages coming from the store will flow through the topic, flow through that subscription, and arrive at the inventory system on the back end. But I've also created this other tap that I'm using for auditing. So maybe I'm writing all of the sales transactions to a database or to a log file or something like that. Next thing I'm going to do is to provide some insight for the manager. So I've created this dashboard application. This dashboard application also has a subscription on that flow of messages, so he can say in real time what's happening. And then for the analysis, we've had this analyzer application, and I've hooked that up to a subscription on this topic as well. Now the output from the analyzer, I'm publishing that into another topic, and that has a subscription that's going to the dashboard. So the dashboard is seeing both the real-time data, but also the analyzed data. And what the analyzer is doing in this app, it's actually using Stream Insight, which is our complex event processing engine. And it's looking at a 5-second window of activity on the stream and adding up all of the sales grouped by the different products. So you'll see that in action in a moment. Okay, so that's the data flow from the point of sale terminal side. Now another thing that our manager wants to do here, he wants to be able to update the catalogs of products that these points of sale terminals are using. Now in a large deployment, maybe there are multiple points of sales per store, multiple stores. This can be a complex operation. What we're doing here is we're showing the scale-out eventing capabilities of topics. So each of these points of sale terminal, in addition to sending its sales transactions, it's also listening it has a subscription to something we've called the catalog topic. So when the manager wants to add a new product, he sends a message into that catalog topic, and all of the points of sale terminals that have subscriptions to that data will receive that message. Okay, so let's see this in action. So, first thing I'm going to do is start up that data analyzer. And we'll just put that away. And now start up a point of sale terminal. Okay, and I'm going to, there's space here to indicate a name. I'm going to say we're at the build. I'm going to call it build and say our location is Redmond. Okay, I'm also going to start up the management dashboard. I'll put that over here. So I can now go and purchase some products. So a couple of cameras, a laptop, and an LCD. When I hit purchase, that's sending a message into that data collection topic, and this dashboard that has a subscription on that is displaying that tile on the screen. If I purchase something else, let's say I purchase a couple of laptops, 3 laptops, you'll see this get updated with the latest sale transaction from that point of sale. Okay, so this is semi-interesting with one point of sale terminal, but gets more interesting when we have a few. So this is a little utility that's going to go and simulate a bunch of point of sale terminals. Okay, so we can see there's Boston point of sale 3, Philadelphia point of sale 1, etc. So if we go back to our console here, we now see those new point of sale terminals being represented. Now I can also look at the statistics, so I can see the output from our data analyzer. So what this is doing is it's taking a 5-second window of that data stream and adding up all of the sales from all of those different point of sale terminals, and it's rendering those in these bars on this graph. The other thing I can do is I can do filtering. So if I'm only interested in, say, stores from Redmond, I can apply this filter and change the subscription rules so that I only receive messages that have store location equal to Redmond. So that I haven't changed any of the senders or receivers. I've just modified the subscription. And then finally, the last thing I want to show you is the adding a new product. So this is the scale out notification capability of topics. So if I add a new product here, we'll add a printer. And I've got a little picture of a printer here. And I submit that. Then that sends a message to the catalog update topic, and it's received by all of the point of sale terminals that have a subscription to it. So here we can see this point of sale terminal has the printer, and I can go and purchase some. And if we look at the machines, we'll see that some of the other points of sale have noticed that there's a new product, and they are starting to buy printers as well. Okay, so that's brokered messaging. Now, I know you guys all came here to learn about Windows 8, and you've got your new Microsoft Surface computers, and you're wondering, what am I going to do with these? What interesting things can I build? So let me show you something new. So this is an app that's written using the new Service Bus client library for Windows RT. And you'll see that we've got a nice simple API here. We've took the opportunity to create some really nice and easy to use API abstractions. Anyway, if I go ahead and run this thing, so we'll see we now have a lovely Windows 8 style point of sale application, and I can go and I can purchase some things, and I can submit my order. Okay, so I'll put that over there. But back to Visual Studio, I want to call out some other things while I'm here. So as part of SDK 1.8, we introduced some new tooling for Visual Studio. So here I have an Explorer, and there is a tab, a node here in the Explorer for Service Bus. So I can go to this node and I can add a new connection, and I can basically bring in my subscription information from the portal. There's a few ways of doing this. I can go to the portal, present my identity, and get back certificates for all of the various namespaces that I have access to, and then they will be populated in this drop down here. Alternatively, I can do this manually. I can enter a namespace name and issue a name and key, or I can use the connection string and just plonk in the connection string into this box. So once I've done that, I see the namespaces and the list of entities that I have inside that namespace. So you can see this, the data collection topic, and here we have a subscription called Audit. So the other thing to call out here is this properties pane on the other side. So this is giving you real-time insight into the state of your entity. So I can see here that there's an active message count of 1. I can see when it was created. I can see the various properties, when it was last accessed. And this is just fantastic for debugging. It means I can put a breakpoint in my code, and I can immediately look at the state of the messaging entities. So if I put another order in here, submit my order, and refresh this, we'll see that my active message count's up to 2. I can consume messages, so I can receive messages here. We'll see receiving a test message, and then we'll see this go down to 1. Maybe that's my phone. Yeah, and I can do all sorts of operations using this tooling. So I can go and I'll just show you a few other things. I can go in and I can create, there's a lot of queues in this namespace, but I can go in, I can create a new queue. I can put my name in here. I can give it a description. This is new in Windows 8, this ability to put a description for your queue. You can use this to do searching across your entities. We've got a new API that lets you do this metadata search. There's some new capabilities here. We have the notion of relaxing ordering. This is kind of to prepare for something we will be introducing later in terms of massively scaled out queues, where you might want to relax ordering in order to get increased scale. But you can basically control all the aspects of your queue here. So I can save that. And yeah, that now appears here. I can send a test message to that queue, etc. So, you know, it's a really nice, easy to use, rich way of monitoring and managing your queues, or everything from all within the Visual Studio environment. Okay, so that's WinRT. Let me shut some of this down. All right. So back to the slides. There's a whole lot of capabilities that we've added as part of Windows Azure SDK 1.8. There's the tooling experience you just saw, but there's a whole lot of API enhancements and features that we've added to Service Bus. I'm just going to talk through a couple of those. There's too much to cover in this session, and at the end of this presentation there's some links to some more information, but I'll just call out a couple of those capabilities now. So we have this notion of message auto forwarding. So what this allows you to do is to wire together entities, wire together queues and topics. So I can create a topic and create a subscription on that topic and have that subscription auto forward to another topic. Now, there's a lot of value you can get from this very simple concept. So the first is, if you want to do very large publish and subscribe, so you have a very large number of subscribers, say you've got 10,000 subscribers. Our topic today restricts you to 2,000 subscribers. So what you can do now is you can create an input topic, you can create 5 subscriptions, you can create 5 output topics, you can wire the subscriptions up to those topics and hang off 2,000 subscriptions off those individual topics. And that's a way for you to reach ultimately infinite number of subscriptions. The other thing that this is useful for is for reducing coupling. Like, you can create a dedicated inbox style queue for a message sender and a dedicated outbox for some message receiver. And then, using this auto forwarding mechanism, you're free to manipulate the messaging network in between those two entities without even changing the name of the entities that your actual code is baked to. So it's very easy to change the entity that a component is listening to, but that does require a configuration change of that entity. Here you can do it just by changing the forwarding and the network purely within Service Bus without having to touch those endpoints. So that's a very useful capability, and it's very easy to set up, as you can see, with this little code snippet. We've got, like I say, there's lots of other capabilities that we've added as part of SDK 1.8. I'm not really going to talk through those today, but there's more information at the end of this where you can go and hear about those capabilities. Another big thing that we announced just last week is Service Bus for Windows Server. So this is an on-premise version of Service Bus that provides all of the brokered messaging capabilities that you have available in Azure Service Bus and makes those available for you to run on your own equipment on-premise. You can also run Service Bus for Windows Server in an infrastructure as a service provider as well. So why is this useful? So I've got a number of scenarios here. So the first scenario, on-premises publish and subscribe. So all of your clients and services are local on-premise, and you want to do publish and subscribe messaging between them. You can do that by just installing an instance of Service Bus locally and doing all of the wire-up. The second example here is using on-premise Service Bus as a development environment for an application that ultimately you're going to deploy in Azure Service Bus. But this is a really convenient way of being able to develop your applications, debug your applications. You can tweak all of the timeouts so you're not limited by the timeouts that are imposed by Azure Service Bus. So you can get into your debugger and you can take an arbitrarily long time figuring out what's going on. So there's lots of flexibility that you can get by running this as a developer box experience on premise. The third entry I've got here is just this notion of flexible deployment. So I can write an application and I have the choice as to where I want to deploy it. Or I can deploy it locally today. In 6 months I can deploy it to the cloud, or vice versa. So it gives you this flexibility. And finally, tiered deployments. So then, it's often difficult to move everything to the cloud in one swoop. And so typically what you're faced with is a situation where you can take this component, you can run it up in the cloud, and you can take this component, you need to run it on premise. Over time, you might be able to move more of your components from on-premise up into the cloud. And this symmetry of access between Service Bus for Windows Server and Azure Service Bus makes that possible for you. And just to reinforce that symmetry aspect of this, so using the config wizard or a commandlet that we provide with Service Bus for Windows Server, you can get the connection string, and then you put that connection string in your app config file, and then you use it in your code. Now, that connection, the way you're using it in the code is identical whether you're using Azure Service Bus or whether you're using Service Bus for Windows Server. The only difference is that connection string. So I can go to the portal and I can get a connection string from a namespace up in Azure Service Bus and put it in there, and everything will continue to work. So that's a really powerful symmetry between the two runtimes there. Okay, so next up, cross-platform hybrid applications. So far, all of the discussion we've had about brokered messaging has been talking about the nice application structuring patterns that they provide. So you get temporal decoupling, load balancing, load leveling, topic support, all those variety of patterns, fan in, fan out. You have all of those capabilities that you get from message-oriented middleware. But traditionally, message-oriented middleware has been as much about that as integration. So this is a definition that I just pulled from Wikipedia, and you can see how it talks about modules being distributed over heterogeneous platforms and applications that are spanning multiple operating systems. So this integration aspect is something that's inherent in the notion of message-oriented middleware. So traditionally, the way this has been achieved is that a vendor would write client libraries for the different platforms that their customers want to use. So you'll get a client library for Windows, you'll get a client library for Linux. Some of the more popular message-oriented middleware vendors take this to the extreme. So they might support large numbers of platforms, including esoteric platforms, old versions of VMS and the like. Because in order for, when you settle on a messaging substrate for your system, you want to be able to connect everything to that messaging substrate. It's no good to saying, I can connect these things, but not those things. So one way of achieving it is doing exactly that, is writing client libraries for your broker for all of those different platforms. But that has some problems in that it means that communication between those client libraries and your broker is a proprietary protocol. So this means that it's difficult to port your application. Should you become dissatisfied with your vendor and you want to take your application to another middleware product, then you're baked into his APIs. So you've got to recode your components, you've got to find another product that has a comparable feature set. Very, very difficult. It's also difficult to integrate. So this is a really common situation where you start off with a couple of systems inside your organization that are independent. And then you embrace service-oriented architecture, you try and pull everything into an integrated whole. You want to write a new application that's pulling data from these disparate systems. So to join those messaging systems together, if they're using different proprietary protocols, you basically have to write an application-level bridge that knows how to speak both protocols, and it knows how to transform the message formats, the proprietary message formats between those two protocols. And finally, you're beholden to whatever the vendor decides is an important platform. So if you have a platform that isn't on his list, then you're in trouble. You're going to have to do something else, like write your own protocol that bridges from your platform to some other platform that has the client library to send to the message service. So things kind of get a bit messy. And also, our industry moves really fast. So new languages, new frameworks come along all the time. And, you need to wait for your vendor to catch up and provide that library in order to be able to take advantage of those languages and platforms. So the alternative to this approach is to actually standardize on that Y-level protocol. So if you make that Y-level protocol a recognized standard and you document that protocol, then it means that anyone is free to go and write a client library for that platform. It means it's possible to go and integrate components from different vendors and have them work together without requiring any of these application-level bridges. Microsoft, along with a bunch of other companies, have been working on this problem for quite a few years, and we've been working on this thing called the Advanced Message Queuing Protocol, AMQP. Now, AMQP is an open standard messaging protocol, and it does exactly what I was saying. It enables you to build cross-platform applications using best-of-breed components from different vendors. So what are some of the features of AMQP? So it's an efficient protocol. It's binary and a connection-oriented protocol. It gives you a range of choices around reliability. You can do fire and forget, best effort messaging, or you can do exactly once messaging. It includes a portable data representation, so this is really important. This means it's possible to take a component that's running in .NET and write a message, and the message looks similar to the message format I showed you earlier. So there's some property bag and some body. And it allows you to create that message, send it through AMQP, and receive that message from a Java app and have full fidelity, i.e. have that message pop out of Java and look recognizable to the message that's gone in the other side. So it looks like a message that's got a property bag that contains a string and an int and a list and things like that. It's flexible in that you can use AMQP between clients as a peer-to-peer protocol, or as a protocol between clients and a broker, and also between brokers. And the final point, it's broker model independent. And this was a really, really important aspect of the work we did with AMQP 1.0. This means that AMQP doesn't say anything about the internals of the message broker. Now this is important because the vision of the folks that worked on AMQP is we want AMQP to become as ubiquitous as HTTP. Now for that to happen, there'll be new message brokers that crop up that are dedicated to AMQP. But what about all of those other messaging products that are in the industry today? We want to make it easy for those vendors to be able to add a protocol head onto their existing product and be able to speak AMQP. Or for some open source project to build a bridge that allows a particular messaging product to speak AMQP. And that way, AMQP has a chance of becoming the ubiquitous protocol that is the vision of this group. So we've been working on this for a long time, but this week's an important week. Earlier this week, OASIS, which is a standard setting organization, announced the ratification of AMQP 1.0. And this is, as I said, the culmination of several years of work and by a lot of companies. And you can see, I know it's small print, but you should be able to see on this list that in addition to technology vendors like Microsoft and Red Hat and VMware, There's a lot of user firms, particularly financial services firms. Bank of America, Credit Suisse, Deutsche Börse, Goldman Sachs, JP Morgan. And in fact, this protocol originated out of JP Morgan. And the reason that all of these financial services firms are so interested in this is because they suffer firsthand from all of the problems I described earlier. So they've got 100 different messaging systems, none of which talk to each other. And they want to get to a situation where they can get some ubiquity. They can get some easier integration between those products. Okay, so I'm not going to go through these, but you'll see these are quotes of support from different organizations. And I just want to raise the point that you'll see on this list are companies that aren't always the best of friends, have been collaborating together within this working group trying to address this problem. So we've got VMware, Red Hat, Software AG, Kazing, Microsoft. I know a bunch of others. Yes, sir.
IBM and Oracle.
No, we don't have IBM and Oracle involved just yet. But it's our hope that now AMQP has reached a standard in OASIS. And we've seen several significant users. For example, the Department of Homeland Security, in their Customs and Border Patrol agency, apparently they're the world's biggest users of IBM MQ series. And they made a statement, their CTO made a statement recently, saying that going forward, all procurement of messaging middleware, the products that are bought must support AMQP 1.0. And they're going to give their existing vendors some time to catch up. So it's my hope that we will see popular vendors like IBM and Oracle support this protocol. So that's the standard. So in other news, other big news, we're also announcing today that Service Bus now supports AMQP 1.0. So we have a preview. You can go to NuGet, and if you look for servicebus.preview, you'll find the package. That package includes an updated client library, so that's an updated version of our .NET client that speaks AMQP. And you'll find a developer's guide in there with samples that talk about how to use Service Bus from Java, PHP, .NET, and Python. And we'll be adding other client libraries and other framework integrations to this story as we validate them. Yes?
Premise as well, or just Azure?
Today it's just for Azure. So our model generally with Service Bus is we lead with the service. So new features will first go into the service, and then at the next appropriate on-premise release, we'll get back to symmetry. So it's absolutely our intent to bring this to Service Bus on-premise. So if you think about Service Bus, it's a multi-protocol messaging system. So today we have, I've called it here SBMP as a name for our internal protocol. So our .NET client library today, this is what it uses to talk to the service. So it's under the covers, it's a SOAP-based protocol, fairly efficient, but it's a .NET only protocol. We also have support for HTTP. So HTTP is awesome because it just gives you that incredible reach. Anywhere where you can write a web HTTP request, you can interact with our service, do management operations, send messages, receive messages. But it does that at a slightly lower performance than you get from the .NET side and the SBMP protocol. We provide a bunch of wrappers for some languages to make it easier to do those HTTP requests, because it can get kind of complicated if you're doing it all from scratch. So we've got some wrappers that Microsoft provide. And then with AMQP 1.0, we kind of get the best of both worlds. We've got the high performance and we also have the high reach. And you can talk to our AMQP endpoint from using any community library, any library that supports AMQP 1.0, you can use that to interact with Service Bus. So today, for this release, we've done some validation against a bunch of clients. So for C#, you have our own Service Bus client library. For Java, you've got a couple of choices. We've got a JMS client library from Apache Cupid. So for those of you that don't know, JMS is a very popular API standard for messaging in the Java world. So you can take a standard Java message service app and you can have that running against Service Bus very easily. The other advantage of supporting JMS is that a lot of the frameworks and containers in the Java world use JMS as their interface to the messaging system. So if you're using JEE or you're using Spring, the Spring framework, you can use this JMS provider to integrate with Service Bus, and you'll see how I've done that in a moment with Spring. We also have another Java client library from a company called IIT that make a popular Java broker called SwiftMQ. And we have a bunch of libraries based on Proton. Proton is a fairly new piece of work that's being done within the Cupid project, and it's an engine for AMQP 1.0 that you can use to add AMQP 1.0 support to a broker, or you can use it as client libraries. And we've validated so far against C, PHP, and Python. Ruby and Perl are coming soon, and by coming soon, I mean days and weeks rather than months and years. And then we'll have a JavaScript version as well that's coming soon. Okay, so I've got a little demo of this AMQP support. So let me set it up. This thing is called Picture Magic. And the idea is that I can send an image into the service and have that image be transformed. I can have it inverted or sepia toned or some filter applied on the service. And this is the basic pattern as to what's going on. So I've got a topic, and I have a bunch of subscriptions on that topic. And I have a reply queue that is used to get responses back from the clients, from the service to the clients. So here's a service, the thing that's doing the image transformation, and it's wired up listening to a subscription on this topic. And then I've got a client over here, and what the client does is it listens to the reply queue and it sends its request to the topic. So the request looked like this. So the body of the message contains the image, so this is just binary data, and then there are a bunch of properties on the message. For example, the transform that you wish to apply as a property on the message. So the message has an ID, 1234, and I'm specifying the reply to queue where I'm going to get the response from. So this is a very common pattern for doing request-reply style interactions over messaging. So the client sends that message, it goes through the topic to the transformer. The transformer consumes the message. It sees that the reply to was RQ. It creates a message sender to RQ, and it creates a response message. So that response message has got the transformed image and has updated properties. So it's got its own message ID, and it's set the correlation ID to be the ID of the source message so that the client can correlate the request and response. So that's the basic pattern, and then the response message goes back. But I'm going to run this in a slightly more complicated deployment mode. So first of all, I've got a Linux VM running up in Azure, and inside that Linux VM, I've got a Python client and a PHP client. PHP could be a script, could be a website. I'm going to show you both. And then on-premise, and by on-premise I mean this laptop, I've got a .NET client and a Java client. So these are all sending transform requests into this topic. Now, on the right-hand side, on the listening side, first of all, I've got the transformer. So this is a Java application. It's written using the SwiftMQ client library. And this is the thing that's actually doing the processing of the message. So this is the thing that will take the request, do the transformation on the image, and send the message back through the reply queue. I haven't shown the reply queues here because it gets a bit complicated, but that's the mechanism I just showed on the previous slide. So the transformer does the processing. Now, I've got some other clients that are listening on different subscriptions to that topic. So I've got a little monitor, so another Java app that will show me the pictures as they're flowing through. I've got a .NET application that is taking these pictures and pushing them out to Twitter. I've got an application that's written in Spring, the Spring framework in Java, that is creating an archive. So all of the messages that go through, it's putting them in a web directory and serving those up over HTTPD on a Linux machine. And then finally, I'm doing some broker-to-broker transfer. I've got another message broker, SwiftMQ, which is a popular JMS broker, Java broker. I've got that running in another Linux VM. And I'm going to show how I can do federation between Service Bus and another broker. And then I can have a bunch of subscribers or whatever hanging off that SwiftMQ broker. Okay, so let's start this thing up. So the first thing I'm going to do is I'm going to start up the services. So this is the transformer application, the Java transformer application. I'm going to start that and put it away. This is the Twitter application. So this is .NET. And you can see, if you're beady-eyed, you can see that they're listening to different subscriptions on this same topic, transform request. So put that away. I'm going to start up a displayer. So this is a Java app. This is just going to listen and show all of the request messages that come in. So all of the images that flow through the service, you should see them in this window here. Okay. Oh, and the Spring service. So the Spring is running up on Linux. I'll just show you real quick what the code looks like for that. So I don't know if has anyone here used Spring? So a few people. So Spring is very configuration driven. So to create a new app here, you can see I'm referencing this configuration file. If I look in this configuration file, I'm using something called a JMS template. And I'm wiring up a bean with that JMS template to this program called Example Consumer. I'm also providing some additional configuration information here. So this properties file is the properties file for the JMS piece. And this is just the standard JMS client library. We haven't done anything special to make it work with Service Bus. But if you look here, you'll see that there's Service Bus information, so credential information and the namespace. So I could run that on this laptop, but I'm actually going to do that on a Linux machine. So on this Linux machine here, I'm going to start up that Spring service. I'll put that away. All right. So next, let's start up some clients. So first, I'll show a SwiftMQ client. So this is a Java application again, using the SwiftMQ client library. And first, we will create a connection. And this will be publishing messages into the topic, into the transform request topic. So now I can load an image. So here's an image. This is a SwiftMQ logo. And I can specify a transform. So let's choose the invert transform and send that through. So what we should see now is that image appear over here in the displayer. And it should also be consumed by the transformer service that I'm also just going to restart. Okay, do that one more time. Oh dear. response is being sent, but not rendered here. So let's go up to Linux. So this is a console up in Linux, and I've got a couple of applications here. One's written in Python, one's written in PHP. Oh, even my SSH connection to the Linux machine is gone. Let's try and restart that. Okay. All right. So I was saying I've got a Python application. So you'll see here that you can see how we've got the connection details for connecting with Service Bus, so the credential information and the namespace. And using this API here, you can see I can create a request message and send that request message. I can put some properties on the message and a body on the message, and then receive the response. I can do the same thing with PHP. Got a PHP transformer here. Looks virtually the same. This is again using the Proton PHP library. You see we create the message and send it, and then receive the response message here. So I can run that Python program, and you'll see that it sent the image through, the Python request, the Python image through. I can see that here. And if I look in the file system, you can see I can see this response file. That's the returned response. I can do the same with the PHP script. So I can run that. Again, my PHP image comes through. I've also set up on that same machine, using that same library, I've set up a web page using PHP. So here I can go and browse an image. So we'll take that image. I can apply a transform, hit transform, and I see the response image. Okay, so that's Python, PHP. On the server side, that Spring app probably needs, does that need a restart as well following the network problem? I think it does. Let me just restart that. Oh, this has died. So we'll run that again. So that's now pulling the messages from that subscription. If I F5 here, I should see those messages appear in this website. So that's produced by Spring. I should also be able to go over to Twitter and see if we have anything over here. Okay, nothing here. So I probably need to restart that Twitter guy as well. So if I just run that now, you'll see that it'll go and pull a message, talk to the Twitter API, and push that. Now, Twitter can only handle requests at a certain rate, so I've got some kind of back off here that shows you how I've got that temporal decoupling between the senders and the receivers. So if I go over to Twitter and F5 here, reload here, we should see, okay, we've got a couple of messages here with the photos. Come on, Twitter. There we go. All right. So, I think that's everything I wanted to show you. So just finally to wrap up, and thanks for bearing with me through that. That's what you get for choosing demos with a lot of moving parts. Okay, so just to wrap up. So Service Bus provides you with this unified set of messaging capabilities. Direct messaging with the relay, and queuing and publish and subscribe brokered messaging. I showed you the new WinRT client library that's available now, so you can write Service Bus applications for your WinRT devices. For Windows Azure SDK 1.8, we've got a lot of new stuff. There's the new Visual Studio tooling, and also the new features of the API. We've got Service Bus for Windows Server that was announced last week. So Service Bus for Windows Server, I should have said, is free of charge. So it's included in your Windows Server license. So if you have Windows Server, you can go and get that. Go and get that now. And we're announcing the AMQP 1.0 preview today. So you can go and download that from NuGet. There's documentation on windowsazure.com and a detailed developer guide as part of the NuGet package. And I've got a slide here you can read offline for further information, and that's it from me. So thank you very much.